So in the last class, we are doing past paper of topic deformation. We have done 2 questions tomorrow. So starting with a new question. This is air July 13 P2 question number 3. July 13 paper 2 question 3. Okay, so question is shows a man using a chest expander to increase the strength of his arm. आप सब अवेलेबल हो इस एक्सरसाइज मशीन से आपको पता है कि इसके मिडिल में स्प्रिंग अटैच होते हैं. A chest expander may be considered to be a single spring. Okay. Figure 2, we have a table shows a force needed to produce between the extension of the spring. You can see there is a table of force and extension. All the terms of force are given to you from 0 to 180 and all the terms for extension given from 0 to 30 centimeters, right? Okay, you have to solve this question with me in your copy right now. Part number 8. You can just mention the air for the reference, and if you want to write the whole question, then you can leave this space and do it after the class. But right now, just give me the answer. Part number 8. A man increases the force on a spring from 0 to 180 Newton. The spring expands by 30 centimeters and the average force exerted during the process is 90 Newton. Okay. Total expansion of the spring is given, that is 30 centimeters. Total expansion is given to you, that is 30 centimeter. Okay, they have mentioned you right there. And average force, they are not asking for the total, they are giving you the average force exerted. Average force is 90 Newton. Okay. Part number 1, calculate work done on the spring. They are asking for you to calculate how much work should be done to get the extension of 30 centimeters. Work done. You have to calculate work done here by using the formula of work done. Try to calculate it. Which formula we are going to use? Yes? Any idea? As we have done with the chapter work, energy and power, do you remember what is the formula of work done?
Work is equal to force times distance.
Right. Work is equals to force time distance. So use this formula and calculate the results. What is the force here? We are going to take the average force, right? That is 90. And a distance here is 30 centimeters. The total extended spring is up to 30 centimeters. So we need to take distance in meters. So what you have to do, you have to convert centimeter into meter first. We will get 0.3. Am I right? So what will be the answer? 90 multiplied by 0.3, we will get 27 joules. So this is the answer for part number 8. Okay. What they are asking in part number 2, a 20 extensions are made in 1 minute. So in total 1 minute time interval, they have made 20 extensions, right? They will expand the, the device 20 times in 1 minute. So they are asking for you to calculate power used to extend the spring. Again, they are asking you to calculate power. Okay. So they are asking you to calculate power. What is the formula of power?
Power is equal to work divided by time.
Load divided by time. Okay, a load means a force divided by time. Yes. That means what is the force here? A work done. Formula of power is actually work done divided by time. Work done, power is equals to W divided by T. Okay. Okay. So what the answer we have get from the work done? For the work done, we have 27 joules. So we will write here 27 by time is given to you 1 minute. So we have to convert 1 minute to seconds and we will get 60 seconds. Okay. 27. Okay. But one thing is more here that 20 extensions has been made. So we have to calculate the power for the 20 extensions, right? So what we do, we will multiply by 20 as well. Multiply, firstly we will divide it by 60 seconds here and then multiply by 20 extensions we have made, right? 20 extensions. Because we are going to find out for power for the 20 extensions. Okay. So this is the formula we are going to use for calculating the power, and this is the way we can calculate the power. So what is the answer? Power is equals to, yes, I think 9 volts. Yes. Okay. So this is for both the parts. These both parts are related to the chapter work done. Okay, now let's move towards the other parts. अच्छा, इसके जो पार्ट्स हैं वो पीडीएफ में थोड़े ऊपर अटैच हो गए हैं, तो ये यहाँ पर चले गए हैं. ठीक है, आप देख लीजिएगा. ये आपके पार्ट बी है इसका क्वेश्चन के ऊपर. Okay, part number B. They are asking for the force at the limit of proportionality of a spring is 800 newtons. Okay, for this table, the limit of proportionality force is not given in this table. This table is only for the linear behavior, not for the plastic behavior. So here we don't have a limit of proportionality. So in part number B, they have introduced the value for the limit of proportionality. You know that what is the limit of proportionality means after that limit our spring is going to be show you the plastic behavior, plastic deformation. So the limit of proportionality here is 800 newtons. 800 newtons. And they are asking you to calculate the extension of a spring when force is 100 Newton. Means you have to calculate force now for the limit, at the limit. Means how much force, how much load we are added on spring to get limit of proportionality, right? कितनी extension आएगी हमारे पास अगर मैं load 800 न्यूटन का अटैच करूं? कौन सा फॉर्मूला यूज करेंगे? यस,
F is equal to KX.
राइट, हम हुक्स लॉ यूज करेंगे. दैट इज हुक्स लॉ क्या था हमारे पास? F is equals to K and E, right? And how, but we don't have a value of K, right? So how can we find out the value of K? We will find out the value of K by the
F is
same
equal to
formula.
minus.
Yes, by the same formula. So K will be equal to F by E. Then F by E then. So what we will going to take F here. Yes, 180. You're right. So we are going to take F as 180 because that was the final extension we will get. 180 by, and how much extension we have at 180?
30.
Yes, it's 30. So we will get value of E, that is 6. 6. Okay. 6. And what is the Newton for the spring constant? Unit of force is Newton and unit of extension is centimeter, right? So that is the unit. So you have to write the unit as well, otherwise you will lose your mark because it carries 2 marks. You know, the question carries 2 marks. You can see the question carries 2 marks. So you have to do each and every process to get 2 marks. You have to write the formula and you have to calculate the value of K with the unit, and then you have to calculate force for this. So now we are going to find out the force with the same formula. We are using the same formula to calculate force. F is equals to, quickly find it out. Now you know that what is the value of a K. Find out the extension at force 80 Newton. We have to calculate the extension. So for extension, we can evaluate it like this: force by K. Force by K. Find out the answer. Force here is 800 Newton by K we will get is 6. What is the answer?
133.33.
133, right? 133 centimeters. So at 800 newtons, our extension will be 133 centimeters. So we have completed our part number 1 of B. Now we are moved towards part 2. They are asking you, a force on a spring is increased. Now the force is increased from 800 Newton to 860 Newton. Suggest what happened to the extension now. Now what is the extension now? Think about it. How can you calculate? What do you think? Go to the table. You can see that from 0 to 60, we have a difference of 10. Again, from 0 to 120, we have a difference of 10. And again, from 120 to 180, we have a difference of 10. So what do you think from 800 to 160? How much difference we will get? So that part number 2 is little tricky. So loads are given to you and the table is given to you. So you have to approximate your answer. And you have to do approximation by logic. Right? Because as we can see that after adding every weight, we have extension of 10 centimeters. So definitely after adding again more weights, we will have the same extensions. If we are increasing our load from 800 to 860 Newton, so definitely there will be extension of by adding 10 centimeters more. Sorry, 100, yes, 10 centimeters more. What do you think? Am I right or not? What do you suggest? Yes, students? Yes. Am I thinking in the right way or not?
Yes, मैं समझ गई.
Okay, so our part number 2, answer of part number 2, we will add up 10 centimeter in the extension we will get for 800 Newton. So that is the extension we will get for 800 Newton, right? So the extension we will get for 800 Newton is 133. So we are going to add 133 by 10. The total extension at load of 860 Newton we will get by 133 Newton, centimeter plus 10 centimeter, and we will get 143 centimeters. यहाँ तक क्लियर है? ये बात समझ आई सबको? ये बात समझ आ गई सबको? Yes, students. Saima, Azan, Sarif.
Yes, miss.
सोना से जोहर कुरैशी, ये पॉइंट सबको क्लियर हुआ है? क्योंकि अभी हमने अपने टेबल से देखा है कि जितनी भी हमने लोड ऐड कर रहे हैं एक्सटेंशन हमारे पास 10 सेंटीमीटर की ही आ रही है. तो अगेन जो हम फर्दर लोड ऐड करेंगे वो भी हम ग्रेजुअली ही कर रहे हैं ना, ये हम ग्रेजुअली कर रहे हैं. जैसे आप यहाँ देख सकते हो कि हमारा पहला लोड जो है वो 0 है, देन 60 मीन 60 के डिजिट से हम आगे बढ़ते जा रहे हैं. 60 देन 120, देन अगेन वी आर एडिंग डिफरेंस of 120 and difference between the 120 and 180 is again 60, and you can see the difference between 800 and 800 and 160. Again the difference between both of them is 60, so the extension must be linear between them. So the extension difference between every extension is 10 centimeter. So for the same for this question we have to add 10 to get a required answer. Okay, so we are done with this. We are going to do our another question. यहाँ तक आप लोगों ने कर लिया, सॉल्व कर रहे हो साथ साथ? Question 14. Yes. Okay, now we are doing question number 14. A student suspends a spring from a clamp stand. He measured the unstretched length of the spring with no load. Okay, so first he just hanged the spring and then on the clamp stand, and then he tried to measure the length of the original length of the spring, right? He then attached the different loads to the lower end of the spring and measured the new length of the spring. After adding the loads, he then start measuring the length of the spring, the extension length. Now show how the total length of the spring depends on the load attached. Our time is getting running out. जल्दी से हम कर लेते हैं, मैं आपके अटेंडेंस ले लूं वरना फिर ये turn on your camera. The camera still on. We see everybody of you. Okay, one important announcement as well. कल आप लोगों का एक ड्यू टेस्ट रह गया था टेम्परेचर का, जो कि नहीं हो सका बिकॉज ऑफ दी हॉलीडेज ऑफ लास्ट वीक. तो आप लोगों का कल टेम्परेचर चैप्टर का टेस्ट है, ठीक है? जो भी हमने लेक्चर में किया है उसी को देखना है आपने, उसी से ही टेस्ट मैंने फॉर्म किया. ओके, वन थिंग मोर, ड्यूरिंग क्लास मेरे आप लोग आपका कैमरा ऑन होना चाहिए. सेकेंडली यू हैव टू कीप योर स्पेयर पेपर विथ यू. टेस्ट मैं आपके साथ ग्रुप में शेयर कर दूंगी, गूगल क्लासरूम पे भी अटैच कर दूंगी. आपने मेरे सामने वो टेस्ट रफ पेपर पे सॉल्व करना है. देन आपने क्या करना है, उस टेस्ट पेपर का प्रिंट आउट निकालना है और फिर आफ्टर क्लास उसी को जो टेस्ट आपने किया है उसी को कॉपी करना है टेस्ट पेपर के अंदर. और मंडे से अगर हमारी क्लासेस डिजिटल क्लासेस शुरू हो जाती हैं तो वो आपको अपने साथ लेकर, और गूगल पे मैं एज असाइनमेंट उसको अटैच करूंगी, तो वहां पर उसका स्क्रीनशॉट भी अटैच करना है. आई विल गिव यू वन डे फॉर दिस, या 2 दिन दे दूंगी जिनके पास प्रिंटर अवेलेबल नहीं है, ताकि वो प्रिंट आराम से करा लें और फिर अटैच कर दें, ठीक है? लेकिन पेपर आपने मेरे सामने बैठ कर सॉल्व करना है. आपको जो मैं टेस्ट दूंगी मेरे सामने सॉल्व करना है. 10 मार्क्स का टेस्ट है, राइट? आपको पता है कि मैं जो भी चैप्टर कंप्लीट करती हूँ उसके बाद एक टेस्ट कंडक्ट करती हूँ, तो आप उसके लिए प्रिपेयर रहे करो. जो भी चैप्टर आपका कंप्लीट होगा उसका एक टेस्ट होगा आफ्टर कंप्लीटिंग ऑफ वन चैप्टर. ओके, आज तो ये हमने देख लिया था. अब नाउ वी हैव अ ग्राफ हियर. You can see a graph here, and the graph is for the original length as well, right? Starting from the original length plus extension length. Means यहाँ से start हुआ है from 0 to 10. That means from 0 to 5 and 6, 7, 8.5. That is the original length, right? And after that, that is the all extension because of the loads. Come to the part number A. A point P on the figure 1.1, you know that what is the point P? A limit of proportionality, right? The line star being straight and begin to curve. State the name of the point P. You know that what is the point P here? What is the point P? I'm asking for this point.
Limit of proportionality.
Yes, so you have to just write that what is the limit of proportionality. So point P is actually the limit of proportionality, right? But इसमें सिर्फ ये नाम लिख के आपको 1 मार्क मिल जाए. आप लोगों ने मेरे साथ साथ सॉल्व करने हैं ये, ठीक है? ओके, part B, using the diagram determine the unstretched length of the spring. Okay, now by using the graph you have to find out the unstretched length of the spring, means the original length of the spring. So look at the graph and find it out. What is the original length? You can find it out what is the original length by adding no load, means zero load. That is the load at the x-axis, and means at zero load what is the length? At zero load what is the length? So that is the length at the zero load. So you can find it out because here the two digits are equal to one. Two boxes are equal to one digit, right? 1 centimeter. So after two digit, that is 6, that is 7, then we have 8.
8.5.
Yes, we will get 8.5 here. Answer is 8.5 centimeters. Okay. So answer of A, we have done. A part, B part A. Okay. Come to the part number 2. Calculate extension of spring for a load of 4 Newton. Okay, come again to the graph. 4 Newton, we have to calculate the extension at 4 Newton. Four Newton. So that is the 4 Newton, and what is the extension at that point? Find it out. At 4 Newton, what will be the extension? That is the value at 4 Newton, and our extension will be, you can see here, so that is the value for extension is approximately 11, then we have 12, that is 13, 14, and 14.5. इसको आप अपने पास भी जब उस पे करोगे ग्राफ पेपर पर इसको क्वेश्चन को जब लोगे आप इसका प्रिंट आउट ले लो या जिस तरह भी इसको अटैच कर लो, आप वहां पे देख लो कि आई थिंक इट्स नो 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 एट दिस पॉइंट हियर, दिस इज द पॉइंट हियर, not this one. Okay, so we are getting approximately 15.5 for 6. We are getting 15.5 for 6. Right? So that is the answer for part number 2. Part number 2. B part number 2. B part 2. And this is the answer for B part A. Part 1. Sorry. Okay. let's move towards other one. Part number C. The student attaches a small block of wood to an identical spring. Okay, now he is using the same spring, but now he is going to attach small block of wood. The extension of the spring is now 2.7 centimeter, and the gravitational force is given to you. They are asking for you to calculate mass of block of wood. How can you do it? What is the formula for calculating the mass?
Weight upon gravity, force
Okay.
upon gravity.
Force over gravity.